Welcome to this session. In this session, we are mainly going to talk about certain basic definitions. We would try to define what system is, and then we would move on to defining what is a computing system, what are components of a computing system, and then finally we will try to define that what OS is. We would also try to see that what are the various issues associated with the OS designing. So, let us just define what a system is. So, system is defined as a collection of a component organized to accomplish a specific function or a set of a function. Another definition, if we just try to see, a system is an assemblage of an interdependent, interrelated element forming a unified whole. The next question which we need to answer is, what is an operating system? A system that helps in operating a computing system. That can be a very simple definition. And the goals of an operating system are going to be provide ease of operations, provide efficient resource management. As the computing systems, they contain large amount of resources. It is important that efficient uses of these resources should be carried out. You would have noticed that OS is something which is OS is a program which is self-loading and self-executing. You would know that you don't require to load the OS, or you don't require to execute the OS. OS kernel, another important aspect is that OS kernel is the code which is running all the time. Let us look at a basic computer block diagram. If you try to see, you find that a computer has a something known as a computer would have a set of input devices, computer would have output devices, and you have a certain section which we call as a CPU, and inside a CPU you find that you have a memory, central control unit, ALU, and all these things are connected together in a specific manner. And they are capable of, this is a device which is capable of executing a program. From this diagram we can clearly see that the main components are our CPU, also known as a processor or a microprocessor. Then you have a memory where programs or data is stored. Then you have I/O devices. So, these are the three main components of any computing system. How these main components are connected with each other? So, we find we have a processor. A processor will have a set of lines which is known as a data bus. Data bus is the set of line which is responsible for carrying the data from memory or I/O device, or carrying data to memory or I/O device. Processor also would have two additional set of lines. One is known as a address bus, and address bus is responsible for carrying the address of I/O devices or address of the memory location. Control bus is responsible for specifying the control signal to the various devices and memory, such as it is the control bus which tells the memory whether the operation which is required to be performed is a read operation or write operation. So, a processor will have three sets of buses: data bus, control bus, address bus, and using these buses, memory and I/O devices, they would be connected to form a complete computing system. If we look at a computer system organization, it is possible that one or more number of CPUs, devices, device controllers, they would connect through a common bus. So we notice that this is a common bus through which the devices are, CPU is connected, disk controller, and through this controller our hard disk is connected. Then we have of lately we find that we have input devices such as a mouse, keyboard, they get connected through a USB port, and for that, for handling the connection, USB controller is required. Similarly, the monitor is connected through a graphic adapter. So we find that all these devices and memory, they connect to each other through a common bus. And we should also understand that current day technology permits CPU and devices to work concurrently, meaning to say CPU could be executing a program, whereas a disk controller could be fetching a data. So both these operations can be simultaneously occurring. If we just try to see how a computing system, a complete computing system looks like, so we find that it contains a certain thing. It would contain piece of hardware such as a disk controller, graphic adapter, all those things are piece of hardware. Then on top of it, what we have, what we call as an operating system. We'll try to learn more about the capabilities and functions of operating system in coming time. And these two things put together, the hardware and operating system, they lay the foundations where the various applications can be ported and they can be supported. So applications like a compiler, assembler, text editor, databases, all these are applications, and all these things put together, they form a computing system, and which is essentially accessed by the user. When we talk about a user need not be a physical human being alone. At times user can be a machine as well. So we just try to briefly see that what are the hardware components and what is a hardware. A very simple definition for a hardware would be that it is a piece of metal when dropped would probably make a sound. The various components of a hardware which are going to be there in a machine are processor, also known as a microprocessor. There are a variety of different kind of processors which are existing in the market. For an example, Intel markets a whole bunch of a processor which is a Pentium, or you would have of lately heard about i5, i7, i3 processor. Then you have a memory. Any computing system you would have heard that contains a certain amount of a memory. Most of the time, if you look at a specification of a computer, you would find that it is said that machine has a 4 GB RAM. So what essentially we are talking about? We are essentially talking about a primary memory, which is dynamic RAM, which is a 4 GB. You would also find that it is mentioned cache. System has a 2 MB of a cache, which is essentially a static RAM. Of lately, cache is most of the time cache is on a processor chip itself. Then we have something known as a secondary memory, that is our hard disk. We would have IO devices like a keyboard, monitor, joystick, etc. And internally, all these devices, they are connected through a variety of buses such as a PCI, IDE, USB, SCSI, etc. The various software components, if we look at, The software components would be operating system, which is the most fundamental, most important piece of a computing system. Then on top of it, the variety of other softwares which are supported are compilers. Compilers are nothing but they are the translators. They're capable of translating programs written in one language to another language. You have assemblers which convert a given program, a program written in assembly to a machine code, text editor, and variety of application programs. We must understand that operating system and computer architecture are tightly bonded. Changes in architecture usually lead to changes in operating system, and the requirement of operating system has led to several architectural changes. This statement we would see throughout the course, where we would find that the knowledge of architecture is must for an operating system designer. The next thing which we need to understand clearly is how computers execute a program. So before talking about how computers execute a program, let us see that what a computer program is. Computer program is defined as a sequence of logically arranged instructions written to perform a specific task with the computer. For an example, you could be interested in finding out, calculating the income tax for a given year, or you could be interested in calculating the interest on on your FD which you have in a bank for the period of 3 years. So these are the set of these are a kind of applications where, or these are the kind of applications which you could be programming and which you could be solving. So as we said, that program is nothing but it is an assemblage of instructions, logically arranged instructions, instructions to perform a specific function. So let us first understand that how the instructions, various instructions are going to be executed by a computer. So every single instruction has an associated operation code, which in short we call opcode. So what the processor does, the very first thing processor does is it fetches the opcode, and after having fetched the opcode, that is after having read the operation code from the memory, the processor internally decodes that what operation is required to be performed. So based on the operation required to be performed, it could either fetch a operand. If suppose the operation requires a additional operand, then it will fetch the operand, read the operands from the memory, and then execute. Or another way could be that in case opcode, in case operand is not required, then after the decode it can directly go and execute the instruction. And after executing the instruction, the processor will try to fetch the next opcode, that is, it will get ready to execute the next instruction. So if we just try to list down the steps involved in instruction execution, they are as I had already mentioned, that every instruction is associated with an operation code, and processor decodes the opcode to determine the required operation, and if operation requires operand, then it fetches the operand, and after fetching the operand it executes the instruction. I have just listed assembly instructions supported by Intel processor, add AX comma BX. We can simply understand that AX and BX are the two operands which are to be added, and result is to be produced. So we find an instruction add when it will be decoded, the system would know that it is an add operation, and the operation performed is AX is added with the BX, and the result is stored in the AX. So this is how an instruction would execute by the processor. We should also understand one thing, that a program can execute only if it is loaded in primary memory. We have several types of a memory in a given system. To begin with, let us just keep things simple. There is a part of a memory which we call as a primary memory or main memory, which is made up of RAM. More precise, that it is made up of dynamic RAM. So any program, if it has to be executed, it has to be first loaded into the memory. Usually programs are stored on the hard disk. That is our secondary storage. So from secondary storage to primary memory or main memory, program is required to be loaded before it can get executed. As we have seen that program is required to be loaded into the memory, there are quite a few issues which immediately crop up. The very first question which arises, who loads it in memory? Whether user is going to load into the memory, or it is system on its own based on a user requirement would load it into a memory. In case such a thing, let us take that a user is required to load the code into the memory. It's really going to be very cumbersome, where machine code has to be written into thousands of a memory location, and each bit by bit it has to be written, and it can be really very complex and very cumbersome. So the question is, who loads it in memory? Secondly, second question, having decided, let us assume that somebody would load. The second question which immediately crops up, that how much memory is required by a program? Who would decide? User would decide, or a system would decide, or is there a way by which it can be directly known that what is the size of a program, and then it can be decided that what is the amount of memory which is going to be allocated. Next question which is required to be answered, who decides where the program in memory is loaded? We have a memory which is a contiguous location, whether the program is going to be loaded in the beginning of a memory, or the program is going to be loaded toward the end. Somebody needs to decide where the program is going to be loaded. The questions like whether a given program all the time will get loaded at the same memory location, these are the questions which need to be answered. Having loaded the program in the memory, the next question would be how and when the execution would begin. Another important question, once the program starts executing, how the program would access memory, or how the program would access a device. There can be many more things to be answered. When we are talking about program being loaded into the memory, another question which arises, can there be more than one program which can be loaded into the memory? And these programs could actually be belonging to same user, or could be belonging to the different user. If the answer for this question is going to be yes, which is the fact, which is most of the current day operating system, they allow multiple programs to be loaded into the memory. The immediate question arises, how to guarantee the territorial integrity, meaning to say that a particular program occupies some memory location, another program occupies another memory location. So now how and who is going to protect one program from encroaching the area belonging to the another program, and one program for damaging the area which is belonging to the another program. So this is what we call as maintaining the territorial integrity of various programs which are going to be there in the memory. Not only so there are requirements in terms of maintaining the territorial integrity. There is also a possibility that certain information which is required to be shared across the program. I could be having something which I need to share with all various programs which are executing in the system. So how do we share the information? There should be a method and mechanism for sharing. And once multiple programs are loaded into the memory, again the question would arise that which particular program will run first. And which particular program would run first? The approach here adopted should be that fairness, that is program which probably came first should be executed first, or it can be some kind of a priority where a program which is very important, important program should be executed first, and a non-important program should be executed later. So some such kind of a thing can be done, but the question arises, who would do it? Similarly, for each of the program, how much memory should be allocated? Should it be that whatever is the requirement, whatever is the complete requirement of a program, that much memory should be allocated to each program, or allocate only that much amount of a memory which is necessary at that particular point of a time? So these are the various questions which are needed to be answered as soon as we say that a program for execution is required to be loaded into the memory. And the question is, who would perform all these functions? What is whether it is the user which is going to carry out all these functions, or it is there is going to be some kind of a support coming from the computing system. We can very clearly see the complexity involved in this case. If user is required to carry out all these tasks, all the above mentioned tasks, then we can very clearly see that user really needs to be an expert of a computing system. Until unless the user is expert, user would not be able to carry out any of these functions. So the basic crux is that bare hardware is not enough. We need some component which will act as a hardware resource manager, which will help us to manage the hardware resources which are present in the system. So from this we try to define operating system. We define operating system is a resource manager which is responsible for efficient and optimal resource utilization. We need to understand what the various resources are. So processor is one of the resource. A computing system may have one or more than one processor. Based on a number of processors, which are present in the system, the different kind of operating systems are proposed. We will see this particular thing in a later sessions. Then another resource, that is a memory, which is where all the programs, including OS, would be residing, I/O devices, buses, file system, network. All these are various system resources which are present and which needs to be utilized efficiently. From the user perspective, user looks for ease of operation from a computing system. User also looks for resource sharing, and when we talk about a resource sharing, there can be sequential resource sharing or there can be concurrent sharing. Example for a sequential resource sharing is that a case where we have a machine with a single CPU. So at any given point of a time, an instruction from one program would execute on that CPU. Once the instruction from a given program completes, then instruction from another program can be executed by a CPU. So CPU is shared across various programs sequentially, one after the other. So this is a case where you have a sequential sharing, and but there can be several such examples. If suppose a computing system has got only one printer, so in that case, at any given point of a time, only one print can be fired on it, where one print request or several print requests can be fired, whereas at any given point of a time, a printer will be serving one print request and rest of the requests would be in queue, and they will be serviced one after the other in a sequential manner. Another kind of a sharing, resource sharing, which is prevalent, is concurrent sharing, where two or more programs concurrently use same resources. Example for such resources of files. It is possible that many of us could be looking at our railway site for finding out the details of train, various trains. So simultaneously, large number of users are accessing the informations. So that is kind of a thing we call as a concurrent sharing. From the systems perspective, operating system acts as a resource allocator. The various system would have a variety of resources, and the operating system would need to keep track of all the resources, and resources in the system will need to maintain the status of all the resources which are present in the system. It would act as a resource allocator based on the resource request. Operating system would handle resource request and resource allocation, and the aim of our operating system is optimal utilization of a system resources. For an example, what we mean by optimal utilization of system resources, let us assume that there is a program which requires a hard disk, which requires a tape drive, which requires a printer. Let's assume that the data which is residing is on a hard disk. So the computer would first read the data from the hard disk, and let's say that it will perform some operation on data and then perform the printing, and these output results are going to be stored onto the tape drive. So if suppose all the three resources are acquired right in the beginning, so when we can very clearly see that when computer is reading from the hard disk, my printer and tape drive is not being utilized. And when my printer is being utilized, probably my tape drive is not being used, tape drive and hard disk is not being used. So this is what we call as a inefficient uses of resources. So operating system aims at optimal utilization of a system resources. An operating system also acts as a control program that manages the execution of a user program. There can be multiple users, and operating system needs to manage the execution of each user program, and it is also responsible for preventing error and improper use of computing system. Broadly, if I try to look that kind of a function operating system does, so we can say operating system acts as a coordinator being one of the function, so where it manages all resources, settles conflicting requests for resources, prevents error and improper use of a computer. Another aspect, another function which operating system performs is a facilitator or service provider. It provides facilities that every program would need. It provides standard libraries. It makes application program easier, faster, and less error prone. We'll see the last point. We'll see in due course of time how this kind of a thing is achieved with the help of operating system. There are certain features where both the things are required. For an example, file system is needed by everyone. So the OS does a job of a facilitator. At the same time, file system must be protected, so it also acts as a coordinator. So there are functions where the facilitator and a coordinator both tasks are performed. There are functions where only facilitator related functions or only coordination related functions are carried out by operating system. We'll see them in greater detail in coming sessions. From the user's perspective, if we just try to see that what are the activities, what are the functions which are carried out by operating system, so we find that operating system must maintain a list of authorized users who would use the computing system. It should have a list of all resources in the system. It should initiate the execution of a program. While the programs are executing, these programs would utilize resources. So the operating system needs to maintain the resource users information by each program, and status of each program. The program, when multiple programs are going to be residing in a memory on a single processor system, we must understand that at any point of a time only one of the program could be executing. Rest of the programs would be in not running a state or not executing a state. So it is the operating system which would need to maintain the status of a program, whether maintain the status and need to know that what is the status of a program, whether the program is in running a state or not running a state. And we should understand this is vital from the perspective that a given program has to be executed at some point of a time. So in nutshell, we would say that operating system needs to maintain the current status of all the resources. It needs to carry out the allocation of resources to programs when requested. When multiple programs are there, operating system needs to schedule one of the program for the execution, so it needs to perform it performs the scheduling operation, and as earlier also mentioned, operating system tries to maintain, tries to provide a protection for the information. The goals of a operating system designer, some of the goals of a operating system designer are, one of the thing is provide user interface for ease of operation, which is one of the very fundamental thing. So in a earlier time we find that a command line interface was provided. The examples for such interface is a Unix system and MS-DOS, which gave you a command line interface where on a command prompt user can type in a command and execute the command. More recently, graphical user interface came, which is also known as a GUI. Example for GUI is a Windows Pack, etc. So that is one of the goal. Then the next goal is efficient use of a hardware and a software resource. The very important aspect is maximize the system performance. We would need to understand how do we define, how do we say that a system is performing well, and what are the performance measuring metric. We'll try to see them in a coming sessions. Protection and access control, which is essentially to say that who accesses what, whether every user would access all the information present in the system, or each user would access its own information. This is what is needed to be provided. So protection and access control is a vital goal. Similarly, as a designer, ability to evolve, the ability to evolve and offer new services is very important, because it just happens that every other day certain new devices could be getting developed, and these devices, the input-output devices probably would be needed to connect to the computing system. In that case, these new devices are needed to be supported on the computing system. That means that we need to have a ability to provide new services as and when it is required. The last but not the least important goal is operating system footprint, that is the amount of memory which is used by operating system should usually be kept in control, should not become very large. As we said that performance efficiency, so the question arises, can we measure system efficiency, or can we measure system performance or user convenience? The answer is yes. Efficiency, we can think in terms of a CPU efficiency, for how much period of a time CPU is kept busy executing the program. System performance can be measured with the help of a throughput, that number of programs executed over the given period of a time. User services, user convenience can be measured with the help of a turnaround time, which is sort of a time taken for the user when he submits the program and when he receives the results. So there are ways, there are matrices using which performance can be measured. Thank you.